Right, good morning everyone. Well, people, today we're going to do the application of calculus. What I will focus on today is mensuration, which is basically the grade 10 and 11 work. You do it in grade 10 and they only ask it in grade 11 and 12. So instead of you learning a lot of formulas, I'm going to show you a very short way so that you can remember the formulas. Right, people, I'm going to start off with the basics. The volume of a cube is side cubed. The volume of a rectangular prism is length times breadth times height. The volume of a cylinder is pi r squared times height. So instead of you learning all these, I'm going to teach you that the volume, the generic formula for the volume is the area of the base of the right prism multiplied by the height. The surface area is twice the area of the base plus the perimeter of the base times the height. In order for you to be able to use the generic formulas, I am going to go back to the primary school formulas, and all you need to do is to replace the primary school formulas for the area and the perimeter into the generic formula for the volume and the surface area in order to be able to get the formulas for that. If they ask you the surface area or the volume of a cone, a pyramid, or a sphere, they must give you the formulas. So according to the syllabus, all right prisms, you need to know the formulas. But when it comes to these three, the formulas will be given. Let's look at the following. People, everything is in your notes. It's on the last page, the second large page. You don't have to write down anything. You just need to listen. Right, people, this here is a square. Right, and a square is side times side. So the area here is equal to side squared. The perimeter is the outside edge. So it is side plus side plus side plus side. So the perimeter is equal to 4 times side. This here is a rectangle. And a rectangle, we've got the length and we've got the breadth. So the area is equal to length times breadth. And the perimeter is, that's length, that side is length, breadth, and breadth. So the perimeter is twice length plus breadth. That is the formula for the perimeter. These are primary school formulas. This here is a circle. And the area of a circle is pi radius squared. And the perimeter of the circle is 2 pi r, or twice the radius is the diameter. So another formula for it is pi d. 2 pi r or pi d is the perimeter of a circle. If we look at a triangle, the area of a triangle is equal to half base times perpendicular height. This here is the base, this here is the perpendicular height. So the perimeter of a triangle is side 1 plus side 2 plus side 3. So the perimeter is equal to side 1 plus side 2 plus side 3. Now we're going to use these formulas in the generic formula for the volume and the surface area. Let me explain to you. We know that the volume of a right prism is the area of the base times the height. Now people, if we look at a cube, remember a square is on a flat surface, but this here is three-dimensional. And a square which is three-dimensional is called a cube or cuboid. Now the volume is the area of the base. The base is a square. So the volume is the area of a square, which is side squared, correct? Side squared, times the height. So it is side times side, and the height is also a side, so the volume is equal to side cubed. Do you all understand that? The volume is the area of the base. The area of a square is side squared, and the perpendicular height is also a side. So it's side cubed. In this case, the surface area of a cube, it's twice the area of the base plus the perimeter of the base times the height. Now what is the area of a square? in this case, the area of a rectangle. The area of a rectangle is length times breadth. So that is the length, that is the breadth, and this here is the height. Correct. So it is the area of the base, which is length times breadth, times the height. And that will give you the volume of a rectangular prism. The surface area is twice the area of the base. So the area of the base is length times breadth, plus, in this case, the perimeter of the base. So the perimeter of a rectangle is twice length plus breadth times height. The perimeter of the base times the height. I put the area of the rectangle into the formula, the area of the base times the height. I put the perimeter of the base into the surface area, twice the perimeter of the base times the height. Do you understand? So you don't have to learn all these formulas, just use the generic formula and replace the primary school formulas into the generic formulas, and that will give you the formulas. Right, the cylinder. The volume of the cylinder is the area of the base. The area of a circle is pi radius squared times height. It is the area of the base times the height. The base is a circle. The area of a circle is pi r squared times height. People, I think you got it now. Okay. Right, what is the surface area? It is twice the area of the base. The area of the base is pi radius squared, plus the perimeter of the base. Now the perimeter is basically called the circumference. The perimeter of a circle is called the circumference. So the circumference here is 2 pi r or pi d times the height. Does that make sense? So in this case, the last right prism here, people, is a triangular prism. We name a prism according to the base. If the base is a square, it's called a cuboid or cube. If the base is a rectangle, we call it a rectangular prism. If the base is a circle, we call it a cylinder. If the base is a triangle, we call it a triangular prism. So we name the right prisms according to the bases. The volume is the area of the base. What is the area of a triangle? It is half base times perpendicular height times h, where this here is h, this here is the base, and this here is the perpendicular height h. Does it make sense? And the surface area is twice the area of the base. So twice the area of the base is half base times perpendicular height, plus the perimeter of the base. The perimeter of a square, of a triangle, is side 1 plus side 2 plus side 3 times the height. Does it make sense? So people, that's the quickest way to learn the formulas. Use the generic formulas and replace it with the primary school formulas, and you will find the volume and the surface area of the right prisms. If they ask you the cone, I'm going to do the sphere and the cone. I'm going to do the cone with you just now. If they ask you a cone, a pyramid, or the sphere, they must give you the volume and the surface area. Now people, even if they give it to you, you still need to identify it. If you turn to the 3rd page of your notes, do you see there's a cone? Okay, and the first, right, it's on your last page before the notes. Do you see there? There's a cone. Now they give you the volume as pi r squared times height. What is pi r squared times height? That is the volume of a cylinder. Pi r squared times height is the volume of a cylinder. They give you the volume is equal to length times breadth times height. What is that? A rectangular prism. Length times breadth times height, the volume of a rectangular prism. Volume is equal to 1/3 pi r squared times height. That is a cone. Volume is equal to 4/3 pi r cubed. That is a sphere. So even if they give it to you, you must still be able to identify it. Is that clear? So you need to know your formulas. Are you happy with that? So you need to be able to at least identify it, even if they give it to you. All right. The next. People, let's look at the May-June 2021 national paper. Now you will see in 10.1, people, I will do with you next week. I'm going to sketch the cubic graph by using points. Right, so those questions I will do with you, as well as the derivative graph. If a derivative graph is drawn, how do you interpret it and how do you answer it? That will be done next week. Is that clear? So I'm going to do 10.2 with you. They say, O is the center of a semicircle passing through A, B, C, and D. The radius of the semicircle, the radius here, that there is the radius, and that is given as x minus x squared. So that radius, and that is a radius, because O is the center of the circle, and the radius is given as x minus x squared. They also say to you that x lies between 0 and 1. That's important later on in the question. They say, show that the area of the shaded part is given by that formula. Now, people, let's quickly have a look at this section of work. Right, what do you call a line that goes from the center to the circumference? A radius. If it goes through the center of the circle, it is a diameter. If it goes from side to side, it's a chord. If it cuts the sides, it's a secant. If it touches it by 1 point only, it is a tangent. Right, people, this whole part is called a sector, and part of that is called a segment. Does it make sense? So that is the terminology. The question here is, we need to show that the shaded part, which is a segment, is given by this formula, pi minus 2 divided by 4 multiplied by x to the power of 4 minus 2x cubed plus x squared. Now, let's have a look at the question. People, do you understand that this could be a full circle, correct? So at least we are looking at a semicircle. But how much of the semicircle are we looking at? Do you understand that the angles around a point add up to 360? So if that part is 90 degrees, how much of the full revolution does it represent? 90 divided by 360 is a quarter. So that part there, right, this part here is a quarter of a full circle, correct? So how do we work out the area of this segment here? It is a quarter of a full circle minus the area of a triangle, correct? That will give you the segment. So we can say the area is equal to a quarter of a circle, pi radius squared. It's a quarter of a circle minus the triangle. And the triangle, it is half base times perpendicular height. Do you agree with that? You understand that? So if I take the segment, or if I take the sector, and I subtract the triangle, I'm left with the segment. Right. So now all we have to do is to replace it into that formula. So we can say area is equal to a quarter pi. Now the radius is given as x minus x squared to be squared. That is the radius, and that is squared. The radius is squared. The base here, people, is x minus x squared, and the height is also the same length as the base because these are radii. From the center of the circle to the circumference is a radii, so the base and the perpendicular height is both represented by x minus x squared. So it's a half base, which is x minus x squared, times x minus x squared, which is x minus x ought to be squared. Agree? If you want me to write every line, people, that's not a problem. We can do that. Right. Now, what have we got? This here now is a quarter pi, and this here is x minus x squared minus a half bracket x minus x squared. Now, people, we're going to factorize because the answer is in terms of factors. Something times something is a factor of the expression. So in this case, if we need to factorize, we start off with the highest common factor. Is there a highest common factor? Yes, it is x minus x squared. If there's no highest common factor, we look for the difference of two squares. If there's no difference of two squares, we look for a trinomial. If it's not a trinomial, we look for the sum and the difference of two cubes. If it's not the sum and the difference of two cubes, then we must regroup to find the highest common factor, the difference of two squares, the trinomial, or the sum and difference of two cubes. Is that clear? Those are the steps, grade 10 work of how to factorize. Now, in this case here, we can take out the highest common factor, which is equal to, I'm going to use a different color. This is equal to x minus x squared. That's the highest common factor. So we're going to take that out. This here is x minus x squared, all to be squared. Right, and what am I left with? I'm left with a quarter pi, which is pi over 4 minus a half, correct? Agree. Now, people, in this case, I'm going to find the LCD of 4 and 2, which is 4. So it becomes pi minus 2 over 4, correct? Which is that. And this squared becomes that. So I have shown that the shaded part is given by pi minus 2 divided by 4 multiplied by x to the power of 4 minus 2x cubed plus x squared. Have you got that? Are you with me? Right, people, if you are lost, raise your hand. I will re-explain it. Are you lost? Are you lost on the factorization? Where are you lost? Everything. Okay. Right. I'm going to start. Yeah. Are you lost? Yeah. The formula. Right. Let's quickly have a look here. Right. This O is the center of the circle, correct? What do we call this part of a circle? This part, there's the full circle. Do you see? What do we call this part? A sector. Do you see that? Now, this here is a triangle, correct? And this here is the segment. They want the area of the segment. So what is the area of the segment? It's the sector, or minus the triangle, will give you the segment. Do you understand that? I repeat, the sector minus the triangle will give you the segment, and that is the shaded part. So that is the formula. A quarter pi r squared, a quarter of a circle. Why is it a quarter of the circle? A circle, the full revolution is 360. But the circle is only drawn for 90 degrees of 360. So I'm representing a quarter of a circle. This sector is a quarter of a circle. So it's a quarter pi r squared. And the area of a triangle is half base times perpendicular height. And then all I do is the radius is given as x minus x squared. I put it into the formula. So it is a quarter pi, x minus x squared, or to be squared, minus a half. The base, this here is the base. Now, people, if this here is 90 degrees, we can call this the base and that the perpendicular height, correct? Or we can call that the base and that the perpendicular height. It doesn't matter. In this case, the base and the perpendicular height represents the radius. And the radius is given by the formula x minus x squared. So the base is x minus x squared, the perpendicular height is x minus x squared, and that is x minus x squared, or to be squared. In order for me to find the area is given as factors, a term times a term. So I need to factorize that expression. So I take out the highest common factor, which is x minus x squared. And what am I left with? A quarter pi minus a half. And that I simplify by finding the LCD. How do you simplify the subtraction of fractions? You find the LCD. The LCD is 4. 4 divides into 4 once, times pi is pi. 2 goes into 4 twice, times 1 is 2. Pi minus 2 over 4. And if I multiply out x minus x squared, all to be squared, means x minus x squared times x minus x squared, and that will give you the expression of x to the power of 4 minus 2x to the power of 3 plus x squared. Are you with it now? Okay, people, are you fine with that one? Right, so the next question is determine the value of x which the shaded part will be a maximum. Now, people, to find the maximum or minimum of anything, we differentiate and we let it equal to 0. If we want to find the value of x for a maximum area, we differentiate the area formula, correct? And we let it equal to 0 and we solve for x because they are looking for the value of x which will give you a maximum. Are you happy with that? Now, right, let's quickly have a look here. Now we know that area is given by pi minus 2 over 4 multiplied by x to the power of 4 minus 2x cubed plus x squared. Right. Now, to find the maximum minimum, we're going to differentiate that. So we're going to find dA over dx. Is that clear? Is that clear? Right, people, in this case here. Here we got a constant times something in terms of x. So how do you differentiate that? If we say fx, now people, you need to listen to this, is equal to a constant times x to the power of n, correct? Right, this is the first law for differentiation. So if you want to differentiate, what do? You keep the constant and you differentiate that, correct? So then it is n times 1, which is n, keep x, subtract 1 from the exponent, correct? So if this here is a constant, pi is a number minus 2 divided by 4 is a number, it's a constant. So how do I differentiate a constant times an expression in x? What do? I keep the constant, pi. Okay, how do I, first of all, we have to find the maximum. How do you find the maximum? Differentiate and let it equal to 0. So how do you differentiate this? You keep the constant, pi minus 2 over 4. You keep the constant and you differentiate the expression in terms of x. You keep the constant and you differentiate that in terms of x. So if you want to differentiate x to the power of 4, it is 4 times 1, which is equal to 4, keep x, subtract 1 from the exponent. That times that is negative 6, keep x, subtract 1 from the exponent. 2 times 1 is 2, keep x, subtract 1 from the exponent. And that there is equal to 0. People, are you with me? Are you happy? You understand? Next, this here is a constant. So I can divide both sides by a constant and it changes nothing. So what am I left with? 4x cubed minus 6x squared plus 2x equal to 0, correct? People, you're looking at me as if I come from a different planet. We are from the same planet, okay. Just women are from Venus and we are from Mars, okay. We just think differently. Okay, let's quickly have a look here. Right, in this case, if I've got 2 brackets, x squared minus 2x plus 1 equal to 0, I can divide by a constant. So I'm left with x squared minus 2x plus 1 equal to 0. Then I can factorize, correct? In the same way, I'm dividing by a constant, and I get that, correct? Now I can factorize that. The first step in factorization is the highest common factor, which is 2x. What am I left with? 2x squared minus 3x plus 1 equal to 0. Are you happy with that? So here we can say it is 2x. The factors of that. Factors of 2x is 2x multiplied by x. Factors of 1 is 1 and 1. Same sign, both negative. Correct? So therefore, 2x is equal to 0, x is equal to 0. 2x minus 1 is equal to 0, x is equal to a half. Or x minus 1 is equal to 0, so x is equal to 1, correct? Now, they give me a restriction. X must be greater than 0 but less than 1. So if it's greater than 0, it cannot be equal to 0. And if it is less than 1, it cannot equal to 1. So for which value of x is it a maximum? For x equal to a half. Does it make sense? Are you with me? Okay. Right. People, let's quickly have a look at, I want to do, in your notes, it is on page 2, the second page, at the bottom. I first want to do the cylinder before I do the top one, all right? And the reason for that, I want to show you that you can use the generic formulas that I've just taught you to work out the volume and the surface area. Right, let's quickly look at question 9. Right, people, usually this is a more difficult section of work. That is why I'm taking it a bit slower. And I really don't mind repeating myself or explaining it from a different angle. All right, the important thing is that when you walk out here, you need to understand the work. All right, they say a 340 milliliter can with a height of h and a radius r is shown below. Right, determine the height of the can in terms of the radius. Now people take note. This here is measurement. Right, and we are doing question 9. Now the first thing is 1 milliliter, right, is equal to 1 centimeter cubed. So 1 milliliter represents a volume. And in terms of centimeters, centimeter cubed is a volume, because it is length times breadth times height. It's a volume. So 1 milliliter is 1 centimeters cubed. You understand that? So if I say it is 10 millimeters, then it is, the volume is 10 centimeters cubed if I convert it, correct? This here is a cylinder. So what is the volume? The volume is equal to 340 milliliters, and that is equal to 340 centimeters cubed. Agree? Because of this conversion. They give you the conversion. Right, then they say to you, the height is h, this here is the radius. They say, determine the height of the can in terms of the radius. Now people, what are they given? Do I use surface area or do I use volume? They give you the volume. So what formula must I use? Volume or surface area? Volume. So volume. What is the volume of a cylinder? A can is a cylinder. The volume of a cylinder is the area of the base. What is the base? It is pi radius squared. It is, the base is a circle. The area of a circle is pi r squared times the height. It is the area of the base, which is a circle, times the height is the volume of the can. Now I'm going to make H the subject of the formula. The volume is given as 340. That is equal to pi radius squared times height. Now what do I need to do? I need to make height the subject of the formula. Height is equal to 340 over pi radius squared, and that answers question 9.1. Determine the height of the can in terms of the radius r. The height in terms of the radius r. Pi is a number. Correct. Right, people, in 9.2. They say, calculate the length of the radius of the can in centimeters if the maximum area is a minimum. Now, people, what are they doing? Yeah, they asked volume, but they want the length of the radius. They want the length of the radius if the surface area is a minimum. So I need to use the surface area formula, correct? Now, what is the surface area formula? It is equal to twice the area of the base plus the perimeter of the base times the height, correct? Now, people, in this case, we can say, what is the area of a circle? It is pi radius squared, correct? What is the perimeter of a circle? It's the circumference of the circle, which is pi d, or 2 pi r times height. Agree? But people, what do you need to do? We need to find the minimum area. So we need 2 is a constant. Pi is a constant. Radius we can differentiate. 2 is a constant. Pi is a constant. Radius we need to differentiate. But now we've got another unknown h. So what are we going to do? We need to express h in terms of r, correct? So I'm going to say h I can replace with 340 over pi radius squared. People, are you with me? So now I'm going to simplify that so I can get a formula which I can differentiate in order to determine the minimum surface area. So here we can say that is equal to 2 pi radius squared plus 2 times that is 680, correct? The pi's cancel out, the r cancels out with one of them, so it's 680 over r. Now people, before I can differentiate, I cannot differentiate for r if it's in the denominator, so I need to take it to the numerator. So a here is equal to 2 pi radius squared plus 680 times r to the power negative 1. Are you with me? Now, in order to find the minimum value of r, in order to find the value of r so that the surface area is a minimum, I need to differentiate. So I can say the minimum surface area is given by dA over dr equal to 0. I'm differentiating to r because my expression, my unknown, my variable is r in this case in the formula. Everything else is a constant. So let's differentiate this. This here is equal to 4 pi r, correct? Negative 1 times positive 680 is negative 680 times r to the power of negative 2 is equal to 0. So what do we can say? We can say 4 pi r, I'm going to do every line, minus 680 over r squared equal to 0. I'm going to take that across. So I'm going to say 4 pi r is equal to 680 over r squared. Now I want r the subject of the formula. I'm going to cross multiply. That times that gives you r cubed, correct? And I'm going to divide by 4 pi, so it's 680 over 4 pi, correct? So therefore we can say that r is equal to the cube root of 680 over 4 pi. And if I use my calculator, the value of r is equal to 3,78. Are you with me? Okay. Does everybody understand? Right. People, let's go to question 10. The May, June 2017, let's go to question 10. Right, can I remove this? Right, people, let's quickly have a look at this. I need your attention. Put down all pens and listen. Right, here they say, in this case, the figure above shows the design of a theatre stage, which is in the shape of a semicircle attached to a rectangle. So people, this here is a rectangle, and this here is a half a circle or semicircle. The semicircle has a radius r, and the rectangle has a breadth base, or the breadth b, and the perimeter of the stage is 60 meters. You got to determine the expression of the base in terms of x. So we are looking at the formula for the perimeter. Now people, what is the perimeter here? Now take note. The perimeter is the outside edge, correct? So we can say the perimeter is equal to what? We know that this here is r, so this here is r, correct? So this here is the length, and the length in terms of r is 2r, correct? You agree? And this here is the base. So it is the base, and the outside edge is given by the following. It is basically breadth plus 2r plus breadth, correct? So it is twice breadth plus 2r, agree? And the perimeter is the outside. We're not talking, that doesn't form part of the perimeter. That is the outside. And the outside perimeter of a circle is 2 pi r. But it is half a perimeter, correct? So it's half times 2 pi r. Now, let us simplify. This is equal to twice base plus twice r. Perimeter is 60. That cancels out to give you pi r. Agree? Now they say, determine the expression for b in terms of r. So we've got to make b the subject of the formula. So I'm going to rewrite it. I'm going to do every step for you. I'm going to say 2b plus 2r plus pi r is equal to 60. Then I'm going to make b the subject of the formula. So we can say that 2b is equal to 60 minus 2r minus pi r, correct? So the base here, b, is equal to 60 minus 2r minus pi r divided by 2. So therefore the base is equal to 30 minus r minus a half pi r. People, are you with me? Do you understand that? Okay. That is 10.1. 10.2. They say, for which value of r will the area of the state be a maximum? If they ask for maximum or minimum, we differentiate the formula and then we let it equal to x. So we gain 2. They are asking you the area of the stage, correct? So we need to use the area formula. We need to find a formula for the area of the stage, and then we need to differentiate that formula and let it equal to 0, correct? So what is the area of the stage? The surface area is the area of the rectangle, which is length times breadth, correct? Plus the area of a semicircle, which is a half pi radius squared. Agree? Are you with me? Right, now we need to do is we need to find the formula. So we can say the surface area, the length here is 2r. The breadth is 30 minus r minus a half pi r, correct? Plus a half pi radius squared. Are you with me? And now we need to simplify. Right. So here we can say the surface area is equal to that times that, which is 60r minus 2r squared. That times that is equal to negative pi radius squared plus a half pi radius squared, which is equal to 60r minus 2r squared, and negative 1 pi r squared plus a half pi r squared is negative a half pi radius squared. Do you agree with that? So that is the formula for the surface area. Now in order for us to find the maximum surface area, we're going to differentiate. We're going to call the surface area A. And we're going to say the maximum area is given by the formula dA over dr equal to 0. We are differentiating in terms of r. R is the only variable. 60 is a number. 2 is a number. Half and pi are both represent numbers. There's only one variable. So now we can differentiate. So to differentiate 60r, we're going to say dA over dr is equal to 0. Now we're going to differentiate. I rewrote it. So we're going to say it is 60 minus 4r minus pi r equal to 0, correct? Now you can take that across. Then we're going to get 4r minus pi r equal to 60. I took that across, became positive, and then I just rewrote it, correct? Now we're going to make r the subject of the formula. R bracket 4 minus pi is equal to 60. Now let's just quickly make sure of this. Negative pi r, they got a positive here. Right, people, negative 1. That times that, let's just quickly make sure about that. 60 minus 2r minus pi r. So let's say r is equal to 60 over 4 minus pi. Right, let's just make sure of the sign of that. So here we get 30 minus r minus plus a half pi r. No, it's correct. Okay. Right, people. Where? Surface area, that. Which line? Right, that times that. You said that should be a... Right, as for... Okay, if you take that across, it's plus. Thank you. That across is plus. That is correct. Thank you. Bill, we took that across. Sorry. We took that across so it became, both became plus, and then it works out. Correct. Thank you. Right. Let us look at question 10. You can get as far as that. We'll do question 10. Right, in this case, question 10, they say a rain gauge is in the shape of a cone. Water flows into the gauge. The height of the water is h, the radius is r, the angle between the cone edge and the radius is 60, as shown in the diagram below. The formula for the volume of the cone, there's 4 formulas. Determine r in terms of h, leave your answer in third form. Now people, if they ask you a cone, a pyramid, or a sphere, they must give you the formulas. They have given you the formulas. You still have to identify the correct formula for the volume of the cone, and the volume of the cone is given as a third pi r squared times height, correct? Now in 10.1, determine r in terms of h. Now people, this is a right angle triangle, so we can make use of trig functions. We are given h, that is the opposite side. We are given this here is the adjacent. So opposite over adjacent is tan. So the tan of 60 degrees is equal to h over r. And then they ask you, in this case, to express r. So now we're going to cross multiply r times that. We're just going to interchange that. So r is equal to h over the tan of 60. And the tan of 60 is equal to root 3 over 1. So the radius in terms of height is height divided by root 3, and they ask you to leave your answer in third form. In 10.2, right, they say, determine the derivative of the volume of water with respect to h, and h is equal to 9. So they want us to determine the derivative of the volume. Now the volume of a cone is given by, we identified it as a third pi r squared times height, correct? Now people, do you understand that we cannot differentiate this because a third is a constant. Pi is a constant, but I've got 2 variables. I cannot differentiate if there's 2 variables. But what can I say in terms of r? R I can replace by h over root 3. So that there is equal to 1/3 pi. R is equal to h over root 3 squared times h, which is equal to 1/3 pi h cubed over 3, which is equal to 1 over 9 pi h cubed. Right, is that clear? The next thing is determine the derivative of the volume of the water with respect to h, where h is equal to 9. We want the derivative of the volume. So we can say that dv over dh is equal to 1 over 9 pi times 3 times h squared, correct? Where h is equal to, in this case, h is equal to 9. So in this case, we can say that over that is 1/3 pi 9 squared, which is 81, which is 27 pi. So determine the volume if h is equal to 9, and the answer is 27 pi. Are you with me? Are you happy with that? Right. What I'm going to do, people, I'm just going to do this question, the November 2019 paper. It's got to do with a spider climbing up a wall. Okay. Let's quickly have a look at that. People, I'm going to teach you the most difficult section of work next week, which is the derivative graph. Because when it comes to the derivative graph, the cubic graph, if it's a derivative graph, is a parabola, and the derivative of the parabola is a straight line. It's the most difficult section of work, but I will make it very easy for you in terms of understanding the work. Let us look at, we'll do that next week, November 2019. Right. They said, after flying a short distance, an insect came to rest on a wall. Thereafter, the insect started crawling on the wall. The path of the insect crawled can be described by ht is equal to t minus 6. ht is equal to t minus 6 multiplied by negative 2t squared plus 3t minus 6. Right, is that clear? They say where h is the height above the floor and t is the time in minutes since the insect started crawling. At what height above the floor did the insect start crawling? The insect flew around, landed up on the wall, correct? Then he started to crawl. And when he started to crawl, the shape in which he crawled was given by this formula. So they want the height when he started to crawl. When was that? When t is 0, correct? So when t is 0, we're going to find the h of 0, which is 0 minus 6 times negative 2, 0 squared plus 3 times 0 minus 6, and it's negative 6 times negative 6, and that is equal to 36. Correct? And it's in terms of meters. So he was 36 meters above the ground when he started to crawl. The next thing, how many times did the insect reach the floor? Now people, the height is 36. The floor is, height is 0, correct? So ht represents the height. The height must be 0. So they say, how many times did he reach the floor? He reached the floor when the height was 0. This sounds like a science lesson. Right, so we can say ht is equal to t minus 6 multiplied by negative 2t squared plus 3t t minus 6, correct? So ht is 0. So it's t minus 6 multiplied by negative 2t squared plus 3t minus 6. So therefore we can say that t minus 6 is equal to 0, t is equal to 6, correct? And we can say negative 2t squared plus 3t minus 6 is equal to 0. So 2t squared minus 3t plus 6 is equal to 0. So t is equal to minus b plus minus the square root of b squared minus 4ac divided by 2a. So that is equal to negative 3, which is positive 3, plus minus the square root of negative 3 squared, which is 9, minus 4 times a, which is 2, times c, which is equal to 6, over 2 times a, which is equal to 4. Now, people, do you see I'm finding the square root of a negative number? So therefore, t is equal to 3 plus minus the square root of, that is 48. 9 minus 48 is negative 39 over 4, no solution. So at which time intervals did he reach the floor? Or she, the insect, reached the floor? When t was 6. So how many times did the insect reach the floor? Once. So the insect reached the floor once. Right. Are you with me? Are you happy? People, we've got 3 minutes to go. Determine the maximum height that the insect reached above the floor. The maximum height. How do I find the maximum height? Differentiate the formula, let it equal to 0, and solve for t. Correct. Okay, I'll be quick. Right, 8.3. We can say ht is equal to t minus 6 multiplied by negative 2t squared plus 3t minus 6. Now we're going to multiply a binomial with a trinomial, grade 10 work. First by first, first by second, first by third, second by second, second by second, second by third, simplify. So that is equal to negative 2t cubed plus 3t squared minus 6t plus 12t squared minus 18t plus 36. So this here is equal to negative 2t cubed. That and that is like terms, plus 15t. That and that is minus 24t plus 36, correct? Okay, now we can say to find the maximum height, we can say h prime t is equal to 0. So we're going to differentiate. So that we can say negative 6t squared plus 15t squared. Okay, so we're going to differentiate negative 6 plus 30t minus 24 equal to 0. Here I'm going to divide by negative 6, so I get t squared negative 5t plus 4 is equal to 0. Now I'm going to factorize. That is t, same sign, t negative 4 times t negative 1 is equal to 0. T is equal to 4 or t is equal to 1. Now people, take note. If I substitute t equal to 4 into there, I will get a value. And t equal to 1 into there, and I will get a value. So the maximum height will be the highest value for a specific t value. But I can make it easier for you. Just have a look here. You all understand that this is a cubic graph and the a value is negative. If the A value is negative, I'm going to hell. I start in heaven and I land up in hell. That's the shape of that cubic graph. And on a number line, I've got 1 and 4. I've got 1 and 4. So it is a minimum at 1 and it is a maximum at 4. So the answer is t equal to 4. Does it make sense? Right, that's the quick way, the short way. Right, people, we'll see you next week. Thank you.